Hello guys, thank you very much for coming for our Collections.compare talk. I'm going to do a very good job showing you how many different collections compare to each other. So first, a brief introduction of us. First, Don.
Hey, I'm Donald Raab. So I'll start off saying, a little about who I am. First and foremost, I'm a husband and father, and I'll talk a little bit about what I do. I'm also a managing director at BNY Mellon Bank in New Jersey. Some of the things that I've done, I am the creator of Eclipse Collections. How many people have heard of Eclipse Collections?
Yes, a lot of people.
Okay. It's also a member of the JSR 335 expert group, which was responsible for the great work that wound up in Java 8 in terms of lambdas and the streams API and other neat things like default methods. It was a great honor working on that. I've been a presenter at Java 1 a few times now, I think like 3 times. Also at EclipseCon. I've also done a talk at the JVM Language Summit and also at the Great India Developer Summit. This is, however, my first time at Devox, so very excited to be here today with all of you. So, with that.
Yeah, so I'm Leo Lima. My full name is actually too complicated. So I'm Leo Lima, and I'm a computer engineer. I've been doing software development for 12 years already, only in Java, mostly in Java, and that's what I know now. I'm from Brazil, but now I live in Austin, Texas, and I'm responsible for the technology in my corporation at V2Com. And part of that responsibility is understanding the technology, and we saw that I'm echoing, I guess. No, it's okay? Okay. So part of that technology overview, we saw Java is missing something for IoT development. That's our main core focus on my company, and we got together with some other 2 spec leads, Werner Kayo and Jean Marie, to develop the JSR 363, the units of measurement, and that's already a final JSR, and we are presenting this as well tonight. So that's another area of my interest. Another is collections, so that's, that's why I'm here. And I'm a representative for my company at the JCP Executive Committee as well.
Hi, I'm Nanivadekar. I'm actually a mechanical engineer. It was in 2012 when I joined Goldman Sachs, I wrote my first line of Java code. And it has been a great journey ever since. And working in the collections framework actually exposed me to different aspects of the whole Java programming language and how to write code in general. So my academic background is I'm a mechanical engineer with specialization in robotics and control. I'm a vice president at Goldman Sachs. I'm originally from India. I came in Salt Lake City in 2010, and I've been there ever since. And this is my first DevOps as well, and I'm excited to be here.
Yeah, so this is about Collections.compare, and you cannot start with collections without talking about the Java util collections. And Java util collections has been there for I don't know, almost 20 years now, since JDK 1.2 in '98. And it's a very basic but very critical set of interfaces and implementations and algorithms for working with collections. So when we think about collections, we think about a set of Now I'm on? Yeah, now I'm on. So when you're thinking about collections, when you say collections, it's a bunch of objects, and this bunch of objects on the JDK can be either a map, which is an object pointing to another object, or a collection, which can then be a list, a set, a queue, a deck. But these are the main 2 topics for interfaces. And then JDK provides basic implementations for these interfaces, such as array list is a basic implementation of the list interface. Hash set is a basic implementation of the set interface. So it's been this way, and then as we're going to see how the framework evolved. But we have the basic, we have concurrent versions, we have different algorithms that for sorting, for shuffling, for doing like data manipulation as a add, remove, reverse order, and this basic stuff that you do with collections. And if you don't know, and there is a very good tutorial on the Java Oracle webpage for both the simple version, so it guides you through all the interfaces and all the operations that they're included. And we cannot include all this in this talk, but the concurrent versions as well. And a quick look at how the collections framework evolved since its inception. So it started with a very basic set of operations, as I said before. For many years, it was just that. And then on Java 5 with generics, there's a lot of work done there to make your collections framework more robust and easier to work with less casting and doing more readable code. So also, the for loop was enhanced, so it was easier to work with our collections, and the new interfaces for concurrent operations as well. So then I think it was a very good overhaul of the collections framework. In 2006, with Java 6, we got some new operations, and Java 7, last thing, but with Java 8, with lambdas and streams, we got a bunch of new stuff on the interfaces. So everyone is kind of going back and reevaluating and learning again from, I am learning again, like I just migrated to Java 8, and a lot of new stuff available, so very exciting. And I'm telling you all these good things about the Java collections, and one can wonder why we need something else. So why do we need something that's not Java util collections? And that perspective is when you're working with code, you kind of see new patterns evolving on your code. Like I'm always doing like a collection against a collection. So I do a for A and then a for B inside the for A loop. So that is like a Cartesian product, and that's something that shows on your production code, and you kind of think, hey, there might be something else. This is a recurrent operation, so this could be inside the JDK as well. Another change would be there on JDK you didn't have like the concept of a bag or a map that has multiple values instead of just one object pointing to another object. So there are some types that you end up creating yourself, or then you look around and you can see, hey, this is not just me having this problem, other people have this problem. So that's why we're considering 4 other collections frameworks in alphabetical order here, no trying to sell anyone. Apache Commons Collection has been around for a while as well. Eclipse Collections, which was formerly GS Collection. GS migrated their code to Eclipse. Google Guava is a kitchen sink API slash framework slash library for utilities, and they have a some collection classes inside of them as well. And Java Slang is a functional library to help do functional stuff like Scala, but without having to learn all the language from Scala. And again, on the presentation, you have links for their user guide or documentation, because it's right easy to get started with these libraries as well. A quick view, so they kind of evolved together with the framework. So when Java 2 was around, there was some need for new objects. So Java Collections, Apache Collections was born. And then what I want to point out on this slide is when Java 8 was launched, all these libraries went back and reworked their implementations to use all these new APIs and method references and all this new stuff on JDK 8. So these libraries are there for a while, and they're going to continue there for a while. That's why we chose these 4. There might be others. These are the chosen 4 for our talk. So now I'm going to hand over to Nikhil to do the comparison between and explain a little bit of how we did what we did.
So Leo explained all the collections frameworks that we are going to consider today. So Apache, then there's Guava, there is Eclipse Collections, there is Java Slang, and the good old JDK collections. So in order to sort of get all of them on a common ground, we decided to have our a domain, and we wanted to have a domain which people could easily relate to, or rather it was much more easier for us to explain. So we decided to have a deck of cards. A deck of cards has, as everybody knows, 52 cards. Each card has a rank and a suit, and we end up using enum sets for that. Also, if you see the way the parameters of deck of cards or the member variables are, it's an immutable sorted set for cards. And if you want to have cards by suit, it's an immutable sorted set multi-map. And I'll quickly go over what exactly each of these mean. So the problem statement was we wanted to create a deck of cards where all the cards, like I mentioned before, are going to be in a immutable sorted set. Again, there are some libraries where the immutable part is not present. At that time, we are using the unmodifiable. Libraries like Java Slang, where they are by default immutable, we are just using that. Also, we wanted to group by the cards in an immutable sorted set multi-map. What a multi-map means is you have a key and a collection of values instead of just a key and a value. And Eclipse Collections, Guava as well as Eclipse Collections Guava, they actually have a multi-map implementation. Some of them do, some of them don't, and we have accordingly made the changes. The second thing is we wanted to get the number of cards, and for that we use a data structure called as a bag or a multi-set. It's nothing but a map with the object and the count with it. And last but not the least, one of our problems was we wanted to deal five hands. So what that means is we wanted to have an immutable list of 5 sets of 5 cards. It's sort of a handful to speak, but it was interesting to solve it.
Just a parenthesis here on this is like we imagined, but you can see the operations is something you do on your domain. So on my domain for doing geographical positioning of IoT nodes, I do Cartesian project to connect these points together. I want to group them for a carrier. I want to count how many guys are in a given node as a gateway for how many nodes we have that. So I don't want to explain my domain here, but with this simple domain, we can replicate all these operations and all these code examples to your own domain. So I think it's very useful.
And also, all of this code is available on GitHub. At the end of the slide deck, we have put out the link. And in case our implementation is incorrect or it can be improved, we are open for feedback. And the same talk will be presented next month at Great Indian Developer Summit. And if you guys end up giving us some feedback, yeah, we are happy to accommodate.
There's a thing out there as well. What you'll see is there's a lot more code in the repo than we have in the slides, just because we have limited time. But there are like different implementations. We made different decisions. Like we said, what if we used immutable lists instead of immutable sorted sets, right? And how does that impact things? So.
We are going to go through a few performance benchmarks. We are using JMH, Java Micro Benchmark Harness. It's the open JDK product which is there. All the measures are consistently reported as operations per second. So to make it easy, higher the better. We ran them on my Intel i7 4-core machine, and with 50 warm-up iterations and 30 measurement iterations across 2 forks. Yeah, if there are any changes which we need to do on the JMH side, feel free to give us feedback and we'll try to accommodate.
Yeah, that's also on the GitHub repo. And we didn't do memory operations because the domain is so small. The operations would not have memory impact, but you can always evolve this to your domain and get your memory impact on your code as well.
Yeah. So going to the first problem of creating a deck of cards. We already went through what exactly the problem is. We want to create a deck of cards where all the cards are stored in an immutable sorted set, and all the cards by suit are stored in an immutable sorted set multimap. So if you look at the performance, you would see that for the whole deck of cards, Apache is a winner, JDK is coming close second. And we will see in the implementation why exactly they behave this way.
So what you just saw me do is actually, we also have a deck of presenters up here, so I just shuffled the deck.
Yes.
Right, so first thing we're going to talk about in terms of the deck of cards and help translate in terms of what this means in terms of performance later. First thing we're going to talk about is what types did we have available to use, right? So using JDK, and recall that we wanted to have the deck of cards as an immutable sorted set, right? So we don't have immutable interfaces in the JDK, but you see what we did was we used a sorted set interface from the JDK. And for the grouped cards, where it's grouped by suit, we used a map of suit to sorted set of card. Underneath this, we had to make the decision, because we don't have immutable interfaces or types, we actually decided we have to simulate immutability. We actually wrap the underlying sorted set as well as the map ultimately in an unmodifiable map. And you'll see that later in the code. When we move to Apache Commons, what we see is Apache Commons does not have its own sorted set. So we had to actually use the JDK interface here for the sorted set. But Apache Commons does have a multi-map type. They call it multi-valued map. And there's both a multi-valued set map and a multi-valued list map. They do not have a multi-valued map, though, for sorted sets. And we'll talk a little bit about what the impact of that later. For Eclipse collections, there is actually a type. And you'll see the types that are in blue. If they're blue, they're interfaces. If they're red, they're implementation. And you'll see for Eclipse collections, we actually have, there is an immutable sorted set interface, and there is an immutable sorted set multi-map interface as well. When we move to Guava, Guava actually has an immutable sorted set type. What you see, though, is it actually is a concrete class. I'm sorry, it's actually, I believe, an abstract class. But it is a class, not an interface. There is also an immutable set multi-map. There is no type for immutable sorted set multi-map, however. What you can do, though, is actually store immutable sorted sets in the immutable set multi-map, but you've got a higher type there then. And finally, in Java slang, what you'll see is we have two interfaces for Java slang. There's sorted set and map, and actually looks very similar to the JDK implementation, except for these are completely different interfaces. These are actually immutable interfaces provided by Java slang. Okay, so next thing we're going to show is the sorted set Cartesian product. And what we have here, this is actually a bit of common code. As we were iterating through this particular use case, what we found was that we were writing the same code over and over again. If you look at the bottom, the code we were writing is this pattern called Cartesian product. Now, there is no Cartesian product implementation that we found useful in any libraries. There is actually, I believe, one in Guava and one in Eclipse Collections. But what we wanted, though, is to take something that would actually return ultimately a stream of cards. And what we do here, so for Cartesian product, we have flat map followed by map. And we're applying a function to actually, in the calling code for this, where we're calling, inside stream cards, we call card Cartesian product, pass in the enum set of rank, enum set of suit, pass in a constructor reference for card, and this gives us back a stream of cards. But it's ultimately, Cartesian product is flat map and map together.
So looking at the performance, you can see that Guava blazes through everyone else. And there are reasons behind that. And we are going to go through the code, and Don will end up explaining why underlying it actually ends up behaving the best. And all the other ones are consistently the same. Now, I want to sort of put in a disclaimer out here. Like, one, if you end up running these JMH tests on a different machine, the performance can change, obviously. Also, the second thing is, they're doing 203,000 or 127,000. Like, these are very high number of operations per second, and this is a very small enough domain. So I would consider all of them to be coming closely, but Guava is double, so it's blazing through, right?
Okay, so we're going to look at JDK first, and what we highlight here is just the section of code in the constructor that actually handles Cartesian product. And when we zoom in, what we see, this is the actual code we have for JDK for creating, calling Cartesian product. So we get the stream of cards. That effectively is doing the flat map map. We've now got a stream, and what we have to do is collect that into some type. And recall for JDK, what we want is to come back with a sorted set that's unmodifiable. So what we use is collectors, collecting, and then we do collectors to collection tree set. We get back a tree set. We wrap that in an unmodifiable sorted set. And now we've got inside our pointer, reference for cards, we now have effectively an immutable sorted set. We look at Apache Commons. It's identical. They do not have their own sorted set. This code is no different. We then move to Eclipse Collections. And if we zoom in on the code for this, we'll see something slightly different. So here we actually call stream cards on card, and we convert it to an array. And we're using a special thing. I don't know if folks have seen this before. Stuart, you can correct me if I get this wrong. It's an array constructor reference, right? Is that what it's called? Okay, good. Now, what's interesting in the syntax, this toArray actually passes the int, so it knows the size, right? So we actually get back an array of 52 cards here. And there's actually a factory class called sorted sets. We can get the immutable version of it and basically construct the sorted set, the immutable sorted set directly here. For Guava, what we do, zooming in, we actually take the stream cards, and they have a collector on their immutable sorted set class. You can call immutable sorted set to immutable sorted set, give it a comparator of natural order, and now we've gotten back our immutable sorted set for Guava. For Java slang, similarly, they have a collector on their tree set class. So when we zoom in, you see like we do the stream of cards, we call collect on stream, and we pass in tree set.collector. This gives us back the sorted set type, which is immutable in Java slang.
So going to the second part of the problem, where we want to group the cards by the suit in an immutable sorted set multimap. Now, this is sort of a very important distinction. We want to group them into a multimap which is not only immutable, but the values have to be sorted. And that ends up, if we look at the performance of it, that actually ends up showing that Apache is the clear winner out there. And we will, like, again, Eclipse Collections, Guava, Java slang, and JDK, they are around about there. However, if we look at the implementation, we will actually realize there is a reason why Apache is actually blazing through the rest of them, whereas all the others are sort of hovering out there. And to take it through.
Okay, so now looking in the context, so this is the group by part of the code for JDK, and if we zoom in, what we want, once again, is we want an immutable sorted set multi-map. So we simulate that in the JDK by using unmodifiable map, and then within the map itself, the sorted sets are wrapped in unmodifiable sorted sets. So we do card stream collect, we do collectors grouping by, we then map each element, we're going to use identity for each element, and then we want the collection that comes back to be a tree set wrapped in a modifiable sorted set. And then that whole thing wrapped in an unmodifiable map. So at this point, the whole thing is effectively immutable. For Apache, what we did was we're actually using their multi-map, the set, so Z-valued map. And this is interesting what Nikhil was talking about before. Apache is kind of faster because they don't actually have a sorted set multi-map. So they're getting the benefit of not having to have a sorted data structure. They're just using a hashed data structure here, right? So we believe, our theory is that that's actually what's contributing to the performance here. So the group, by cost is a lot less. They do not have an immutable multi-map, but what you can do is that in their map, multi-map utils class, you can actually ask it to wrap your multi-map as an unmodifiable multi-valued map, effectively making it immutable. With Eclipse collections, when we zoom in, since we're iterating over cards, cards is an immutable sorted set, Eclipse collections provides covariant return types for its different protocols that return collection types. So for group by, we return a multi-map. An immutable sorted set will return back an immutable sorted set multi-map. This is, we have to do nothing else here. We just do cards group by get, suit. With Guava, we find is that we have to actually create an immutable set multi-map builder. And this is where, doing a little bit of Stack Overflow research, I was trying to figure out how do I create an immutable sorted set multi-map. And it turns out you can, on your builder, you call order values by and pass a comparator. And this has the effect of, in your multi-map, they wind up being immutable sorted sets. So we iterate over the cards, we call put on the builder, and then ultimately we call builder build, which is, now we've got our immutable set multi-map. For Java slang, similar to Eclipse collections, you have a nice, Fluent API directly on the collections themselves. You call this.cards group by. This returns you effectively, since everything is default immutable in Java slang, you get back a map of the suit to the sorted set. Now it's interesting, and I haven't quite figured this out, it would be interesting to talk to the creator of Java slang. There is a multi-map type in Java slang, but multi-map is not what gets returned out of group by. So I found that a little bit surprising, but it does return map of a suit to sorted set.
So to summarize, we just went through creating a deck of cards, and that deck of cards is comprised of a Cartesian product and a group by. Now, if you want to put both the images together on the right hand side, which is the Cartesian product and the group by, we will end up getting the deck of cards. You will see all the frameworks are round about the same. All right, the Apache ends up winning very highly in the group by, but it is not that performant in Cartesian product. But at the end of the day, it is performing very well in the holistic view of things. Eclipse collections and Guava, they are coming in around about the same thing. JDK are good old friend. It's always out there with a consistent performance. And again, you have to look at the cumulative value. And then what we did was with the breakdown, now it really depends on what sort of operations you want to do on each of these data structures to figure out. Also, again, your mileage may vary about this.
Yeah, the interesting thing to understand as well is with both Apache and JDK, you're not coming back with immutable data structures. They're unmodifiable wrappers around mutable data structures. They're effectively immutable because you won't be able to change them. But that actually is a trade-off in terms of the interfaces you're getting and then the performance impact. Okay.
So now, like I mentioned before, we are going to the second part of it. We have finally created the deck of cards. Now we know that there are 52 cards in a deck, out of which there are 4 suits and 13 ranks, right? Now, if we want to get at any point of time the number of cards by suit or by rank, then we want a data structure which will help us get that count effectively. So while trying to get the count by suit, you can see in terms of performance, in terms of performance, you can see that Eclipse collections, it has its own bag implementation. So that ends up actually being the most performant. Now Guava also has a multi-set. Similarly, Apache also has a multi-set. If you look at JDK, JDK is actually implemented as a map and a count. And if you look at it, the previous slide showed counts by suit, and you've got only 4 suits, whereas this slide shows counts by rank, where you have 13 ranks. So, I mean, the performance is not that different, but at the same time it is different, and that's because of the number of operations and number of elements that you're working on.
Okay, so the code for JDK to actually support count by, it looks like this. So we have these 2 methods, counts by suit, counts by rank. What we do is we take the cards, we create a stream. We actually do collectors grouping by collectors counting. So you've probably seen code like this before. This will return a map of a suit to long, which is effectively the suits and their counts. For counts by rank, similarly, we do grouping by now get rank, and then counting, we get back map of rank to long. With Apache Collections, this is interesting discovery. Apache Collections actually has 2 bag types, or 2 multi-set types. Basically 2 types that are very similar, right? There's a bag and there's a multi-set, and I consider them the same thing. So what I showed here is you can actually create either of them depending on which one you want. So here though we're doing a stream, we map now get suit and actually collect it into the bag, because the bag actually internally keeps track of the counts. Similarly for counts by rank, we're now creating a hash multi-set and returns multi-set. For Eclipse collections, what we do is we use the APIs that are directly on the collection itself using as lazy, and then we can use Eclipse collections collect method, collect the suit to bag, or collect the rank to bag, and this comes back with the bag type. For Guava, we use the hash multi-set type in Guava, which has the interface multi-set. So we're just streaming, either mapping to get suit, mapping to get rank, and then actually collecting out the hash multi-set in a collector. Now, Java slang was interesting. Java slang does not have a bag or multi-set type that I could find. But what you can do is actually use streams with Java slang, and there is actually a collect method directly on the types themselves. Underneath this, so I actually create the stream for you. But here we pass in the same grouping by counting collector that we used excuse me, for the JDK. And what's interesting is because we wrote this code in the same class as it's in the deck of cards class for Java slang, Java slang, recall, has its own map type called map. And here we're actually returning Java util map. So we actually have to, in this code, specify the path, because now we have 2 map types in the same class.
So going to our last but not the least case, where which was sort of a mouthful to say, it's you want to return a cards as an immutable list which has 5 sets of 5 cards. Okay. So what that means is, if let's say you're playing a game, you have 5 players, each player gets 5 cards. Okay, that's it. And this is where you're actually using the multi-map that you created in the very first the create deck of cards problem statement that we have, and we are trying to use that to get out to deal the cards to each of these players. And if you look at how the usages go, it again really depends on how you're going to deal hands. So Eclipse Collections had its own immutable sorted set multimap. Similarly, Guava had their own immutable set multimap, but you are storing it as a sorted set. And then the way you're creating, the way you're getting these collections and putting them in this immutable sorted set actually ends up impacting the performance, and we'll look at the code.
Yeah, so what we wanted to do for each thing is, once again, we want to return an immutable list of set of 5 cards each. What we do for each deck of cards, we'll create some range. We could have done this with a for loop. We decided to use in-stream range for the JDK. So we go from 0 to 5. We actually then do a map to object, call the deal method with shuffled. Now shuffled is I call it deck, so shuffled is a deck of cards effectively, right? Just the DEQUE version of deck. What's interesting, what we wanted to do is have something that was stack-like, right? Now we didn't want to use the JDK stack. I think the preference these days is actually use array deck and deck. So we use the deck, and we're actually inside of deal. We'll actually pop 5 cards off that stack and then return that as a set. And then once again, we want the whole thing that comes back to be an immutable list. So in the collect method here, we do it to a list, but then wrap it as an unmodifiable list. There's no difference whatsoever with Apache Commons. Recall, they do not have their own sorted set, so the code here is identical. They also use array deck. Apache Commons does have an array stack class. I think it was from a very early version, but what they've done is they've deprecated it, and in the Java doc it actually says use ArrayDec instead, so that's what we used. With Eclipse collections, there is a type called int_interval, similar to int_range, and there's a method 1, 2, and you specify, and this is an inclusive range, so it's 1 to 5 here. Int_interval is a immutable int list, and because we have covariant methods available, like when we call collect, this actually returns an immutable list anyways. So we just do collect, we pass in, and what you see here is up top, it's the type that we're shuffling is immutable stack. So Eclipse Collections has an immutable stack, I'm sorry, has mutable and immutable stack. In this case, we're using mutable stack. It's useful. What we want to do is pop 5 cards. I don't have the code here, but if you look in the deal hand, you would see that there is a special method on mutable stack which takes an int. It's pop with an int, so you can pop off n number of things at a time, thus not needing to write the loop to do pop, 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 pop. Okay, so Guava. The only difference here, it's also using an ArrayDec. It's just what it's collecting into. So there is a collector available on immutable list. You just do immutable list to immutable list, and you've got your collector to collect into. And this was the most interesting discovery I think we made on dealing hands. So Java slang has a stack class. It is an immutable stack, though, which is interesting. When you have an immutable stack, the question is, well, if it's immutable, you don't change it, so how do we deal with pop? Now, it's interesting, when you pop something off an immutable stack, you have to get 2 things back. You have to get back the stack and the thing you popped off, right? And then you have to keep, what you're getting is new stacks every time, and you keep popping elements off, and you're ultimately going to, just be reducing down to some new stack. So it's a little bit harder to deal with the code in terms of doing this, because once again, you've got to keep returning the new stack. And what you get back is a tuple 2 of the set of cards and the stack again, which you can then keep moving stuff off of. So, okay, fun stuff. How visible is that?
It's visible, yeah.
Okay, good. So what we did after going through all this code, once again, there's a lot of code out in Collections.compare, and it's something that I found really interesting looking at, like, we've looked at a whole bunch of features, right? We've looked at immutability, we've looked at like bag, we've looked at multi-map, we've used streams, we've used sets, we've used a lot of different types. We did Cartesian product, which had components of flat map and map. We did group by. We created bags, which otherwise would have been grouping by counting. So a lot of interesting things came out of this very, very simple domain. But there are a lot more other things that we didn't cover, right? And there are a lot of things in these frameworks. So what I tried to do is lay out a set of features in a table here, and then compare across these frameworks which ones you have available. So there's 4 states that you have. It's either yes, green, check mark, no, red, check, X, or there's the yeah, kind of, which is the green check mark in the little box, or not really, which is the orange X in the box. So we looked across all the frameworks for these features, and you see like there's the different types, like list, set, map. Do we have replacements for those? We have multi-sets, bags, multi-maps, bimaps, stacks, trees or tries, tables, additional types. Do you support primitive collections, or you have immutable collections? Do you have a Fluent API? What types of iteration strategies do you have? Do you have lazy, serial, eager, parallel? And then what we tried to do is like group some rankings for each of these feature types, like how the frameworks kind of compare to each other. So this is out there. You want to take a look. And obviously, when you're selecting a collections framework, if you've got what you need in the JDK, awesome, use it, right? And then if you need a specific feature, like if you need a table, Guava has a great table. It's the only thing that has a table out there. Maybe you want to use Guava, right? If you need a whole set of comprehensive things, maybe you want to use something like Eclipse collections. If you have so many possible needs that you can never imagine, maybe you want to use Apache because it's got like a huge pile of functionality we don't even cover in here, right? So a lot of things can go into your selection matrix for a framework.
Yeah, and not only, I want to rephrase here, not only the available features, but also how those are written. So if it's a Fluent API, it's a totally different with when you're using Eclipse collections. You just go with the ... With JDK, you have to do all these static methods or default methods on the interfaces. So that's, I think, is a good way of seeing what's your style of code, and then does this match what I need as well as I'm coding. So that was Also something that I didn't expect, so many different choices of words, choices of how to lay out the code and all that. And that shows on the previous slides as well.
And once you have written your code, try to profile it or write benchmarks for it, because you will be amazed at the things that we found out. So for example, Eclipse Collections, the way the immutable sorted set is created is very different than the way Guava creates their immutable sorted set. At the end of the day, both of them are actually array backed, because once you want to store something for an immutable sorted set, you can actually just park it in an array, because you're not going to change that array. However, the way both of them arrive to it, it's very different. And the reason why they arrive to it is very different as well. So again, your mileage may vary. Make sure you test your code and profile it.
Yeah, don't take our benchmark. These are kind of useless from your application perspective, right? But it did help us learn, like Nikhil is saying, we discovered like in Eclipse collections, when a immutable sorted set is created, we actually create a tree set and then just dump it into an array. And Guava does something slightly more intelligent. Like they build up an array and then they sort the array and then that's what they keep, right? So they actually never create a tree set out of it. Now, there are downside impacts. They're both at the end, just arrays, so they're very memory efficient, but then, then there's the downside. Well, what does a contains check against it do, right? Because, for instance, like Eclipse Collections uses binary search. I'm not sure if Guava offhand, maybe it's linear, maybe they use binary search as well, right? Yeah. So it's like, you might get different trade-offs for like memory and performance. Oops. This is the project, so it's out in GitHub. Doing this exercise and doing this talk for myself was extremely educational, right? I was like sitting down, as a creator of a collections framework, using other people's collections frameworks is kind of interesting, right? You discover like, oh, either that's clever or, oh, I hadn't thought of doing that, or wow, look at these performance things once we start measuring like that they're doing some interesting work, right? And I think it's healthy in terms of the overall ecosystem of collections for people to learn from each other, right? And kind of, come up with a hopefully variety of things that help you all and us all that have to build applications with these things to get the best, features, of possible, right? So we put this out there. We hope that people will take a look at it, and we'll probably be using it maybe for either, other talks about other explorations, right? And the nice thing is with this project, you have all 5 frameworks available in it when you check it out, right? So you can easily, experiment with any of them.
Yep. And that kind of concludes what we had to tell you guys. If you guys have any questions, we are happy to take them. You can also tweet at us. Yep. I think you
Would you mind coming over to the mic?
Yeah.
Oh, and apologies too, since it was our first time using some of these frameworks. If you know better how to use frameworks, I would love to know, because it's very helpful to learn these things. So
how interoperable are these frameworks with each other in the case where I have to use one class from one and one from another?
That's a great question. So I think all of the frameworks provide good interoperability in some way, shape, or form with the JDK. And you got to see some of that through the API. Where there are differences, so for instance, the immutable collections in Guava, I think at the end, they're just JDK types like either set or map, right? So you get immediate cooperation there, right? Where if you use JDK as a common point, of interaction, then you could interact across these different frameworks together, right? All of the frameworks have started, and I think this is where when Leo showed the slide where like Java 8 came out and there's like a flurry of activity and releases, and collections frameworks are like now able to use lambdas and method references and default methods and all this cool stuff, right? And streams as well. And like with streams being available, we get streams in Eclipse collections for free because our mutable interfaces extend the JDK interfaces, right? So we get to use streams. We get to also then interop with JDK types. There are other places, though, where there's less great interop, but there's still interop. So Java Slang, what I found was that their interfaces do not implement the JDK interfaces. So they have their own sorted set. They have their own map. But what they do is they provide methods to translate into JDK types, right? Now, that can be at a cost, potentially. Similarly, like in the immutable collections in Eclipse collections, the types do not extend the JDK types. So an immutable list is not a list, but the implementations implement both immutable list and list. So the implementations are compatible, and you can actually easily, there's a method API to convert from an immutable list to a list if you need to work with a library, for instance, that takes JDK collections. So I would say like the JDK types are the big uniter in terms of the interop, right? Because it's been around for 20 years. So many libraries use the basic types like list, set, and map. It behooves a collections developer to provide interop with these things because other libraries are going to be using them. So it was a long-winded answer.
Hi, I have 2 questions. So first is clarification. On one of the slides, I think it was constructing the, I think it's on now. Constructing the cards where the group by operation, the Apache metrics were like double of kind of the other frameworks. And I think you mentioned you attributed that to Apache not supporting a sorted set or an immutable sorted set.
Yes, so Apache doesn't have an immutable, well, it doesn't have immutable, any kind of immutable set. But so one thing is they only have to wrap as unmodifiable. So they're just using, they're actually just using a hash set. They're not even using a tree set. And I think what we're, which my theory here is that tree set winds up being, slower than hash set to actually create, right? So.
Yeah, I think I would agree.
My theory is that that's where the performance benefits are probably coming from.
But here we are talking about a set valued map. So that's a multi-map where we are talking about the value collection, which is sorted. They don't have one like that. They have the value collection, which is just
only a hash set.
So they might have, like, again, they don't have a, like, they might have a sorted set, but they don't have a sorted set multi-map. So
understood.
That's
yep.
what it is.
Yeah, I think I get it. I think it makes sense, like the difference.
Yep.
I guess the question would be like, is it really a fair comparison to like present those things?
It's a great question. So in some ways, this isn't apples to apples, right? Because in the middle 3, you've got immutable collections, right? And there's a cost to using those, and you get, let's say, then a promise isn't an immutable API, whereas on the outer bounds, you've got mutable interfaces with unmodifiable collections wrapping them. But that can actually be a decision that goes into like how you want to tune your app. If you care about the API, maybe you want to use immutable collections. But if you care, maybe in some cases, maybe unmodifiable collections are actually a better performance option for you, right? Because when I have an immutable collection, I know I always have to create a copy to put stuff in there, unless well, with Java slang, I may be using persistent collections and building up, stuff over a longer period. But like, yeah, at some point, you've got to make sure that no one else has a copy of this thing and it can't be modified, right? So it's a trade-off of like the safety of the interface or implementation versus the performance, right?
Yep, I think that makes sense. So my next question, I guess, you focused a lot on like immutable collections, immutable maps, immutable sets. Did you consider doing like the mutable aspects? Like
yeah, we started writing those, so there's some code out there. Because I was curious, like, how does, let's say, Eclipse collections on the mutable side compare to other things? So we actually have examples out there, but what we wanted to show here is like, this is where we started. Okay. I said, like, let's keep things immutable and sorted set and multi-map and just see how it works out, right? Okay. But then, yeah, then this is one of those things you can determine based on performance profiles. Maybe you want to use a different type, right? So
yeah, because I guess, I mean, depending on the use case, it's probably pretty common to do the mutable, add, remove, like iterate.
We also looked at it as like there's the interesting thing, which is if you look at create deck of cards, that's a startup cost, right? Whereas let's say the count by and the dealing is more a continual cost, right? So it's like could be a trade-off too in terms of the types you use on, in the startup cost and what you care about performance there versus the performance of things maybe I'm going to call over and over and over again, right? Because, Eclipse Collections was performing better on the dealing, right?
Okay, that was it. Thank you.
All right,
Yeah,
thank
sure.
you.
Thank you. Yeah, please come on in.
Yes, I was wondering, I know we had a lot of focus on performance, but I was just wondering if you guys could give a subjective kind of opinion. Which led to the most elegant code in your opinion?
I would ask the question back to you. Which one did you like best, right?
Well,
this was the most succinct, right?
Yeah.
That was pretty nice. I like that.
But then if you look at the other operation, in the end for Java slang is the awful
Yeah,
code.
I didn't like deal hands though. Like immutable stack made me feel
Yeah, so
horrible
for
using
example,
that, right? For it's like, I don't want to use that. So,
so Java slang has a very simple group by operation. Sorry.
Wait,
Let me.
it's like, are you controlling it?
Yes.
Yeah, one of you figure out.
So, for example, this is Java slang, very simple, very easy to read. And if you look at the other Java slang operation for dealing, it's awful. Like compare it about elegance and all that. So I think that's what I meant about a style of API and how you write an API and all that. I like to use JDK because it's been there forever, and I use all their libraries, and that's what I provoke in him, because he is the guy who did Eclipse collection, which is a replacement for everything on JDK. But so yesterday we had the Eclipse collections kata, which was showing all what is available, and the way the Fluent API is designed, like, I think it's very nice. So, and Apache Commons is more like an add-on to the JDK than a replacement to the JDK. So again, it will use mostly the JDK types.
Go back one more. I was pretty happy with the Eclipse collections code as well.
Yeah, so that's the, like, very small, but my main point is, this, for example, looks awful because it's all collectors, collections.
That's an impact side effect too of doing the unmodifiable thing that didn't work well there, right? Because we have a lot of static method calls, right? It's a lot of stuff to accumulate, right? And that's where, like, having additional types is useful for you, right? It's like the cost is then in the framework. You know, some framework developer had to come up with these types for you, and the cost is then removed from your code as a developer, right?
Yeah. So I think it's a matter of taste. Like, we were discussing curly braces when we're developing this code. Like, I like Egyptian style, they don't. So that's where we say, okay, that's one aspect of code that you have to evaluate as well. And I think we did a good job showing you all available possible ways of doing this. And again, in the code there, in the repo, there's a lot of other things that you can take a look and say, hey, this suits more my style. And you hopefully help you choose one for your.
Also, if there's any other domain which you would like to see, because this project can go on expanding, right? It's out there, it's out on GitHub, and hey, if there's one more framework that you would like to put, and if there's another domain for a specific case, like for example, we were writing performance tests for filter and transform, right? But the performance tests are out there, but it sort of didn't gel well with the presentation. Also, there are other implementations with like instead of an immutable sorted set, we have list. Instead of immutables, we have unmodifiables, like all of those things. So again, to answer your question, it depends.
I figured. I just wanted an opinion.
Yeah, and so my opinion, for example, I liked the Apache collections because it's like the JDK. So it's a kind of think the assignment mindset. These guys work a lot with Eclipse collections, so they're going to say Eclipse collections. Otherwise, they would do differently, right?
You are correct.
So I guess that's a subject answer to your subjective question.
I think we are out of time. The next presenter.
Yeah,
Thank you, everyone, for
attending,
spending your precious 1 hour with us and attending. Have a happy DevOps.
Thank you.